Hi, and welcome to our first lesson on solving linear equations. Not surprisingly, the lesson is called Intro to Solving Linear Equations. First thing we need to talk about is our high school definition of solve. If you had definitions of solve from previous grades, they are useless. They might have served the purpose at the time. This one will get you through basically till the end of time while you were doing math. And our definition is we need to find all values of x that make the equation true. In this unit, there is only going to be one solution. There is only going to be one value of x that makes it true. But in the next few units, there will be more than one, which is where this definition gets really useful. Okay, so let's have a look at question 1. Solve. Also notice, solve does not mean find the answer or anything like that. It means find all values of x that make the equation true. So let's have a look at this one. X plus 3 equals 5. Okay, and probably most of you can see that when x equals 2, that equation will be true. If you just write x equals 2, that will get you 1 out of 3 marks. We need to think of the equal sign as the middle of a balance. I'm sure you guys have heard that before. So the left side has to keep equaling the right side, and we need to do something to both sides to keep that equation balanced. In this case, we want to get rid of this plus 3, so I'm going to subtract 3 from both sides. Here we've got 3 minus 3 equals 0, so we've got x plus 0, so I just write x. On the other side, I've got 5 minus 3 is 2. And not surprisingly, we end up with x equals 2. Okay, that's 2 of your 3 marks. The third mark is you need to show me that when x equals 2, the equation is true. So we are going to put in a 2 instead of the x in the original equation. But we also need to let everyone know that this 2 used to be an x. So in the same way as in English class you use a capital letter to mark the start of a sentence, in math class, we use brackets to let everybody know, hey, this used to be an x. Now it's a 2. And now we've just got 2 plus 3 is 2 plus 3 on the left equals 5. On the right, we've still got 5. Does 5 equal 5? Yes. So we made the equation true with x equals 2. Notice our solution is x equals 2. This is our check. Also notice when we do our check, we end up with 5 equals 5, even though the solution is 2. Okay, let's have a look at B. Seven equals x plus 2. Okay, this time we've got a 2 on the same side as the x that we want to get rid of. So I'm going to subtract 2 from both sides. On the left here, I've got 7 minus 2 is 5. On the right side, I've got 2 minus 2 is 0, so I've just got x. Notice, it is fine to end up with x on the right side. In fact, I recommend it because as we get into the more complicated units, there is going to be a difference if we start switching things from side to side. So it's best to leave stuff where it is. The textbook will always have x equals 5 instead of 5 equals x, but they're the same thing. The equal sign just says that both sides equal. Okay, and we're not done yet. We need to show that when x equals 5, our equation is true. So I'm going to put in a 5 in brackets instead of the x. 7 stays on the left side. 5 plus 2 is 7, so I put a 7 on that side. And again, it's true. Okay, let's have a look at C. 6 equals p minus 4. And obviously in this case, we're finding all values of p that make the equation true. I just used x in our definition to make it easier. Okay, so we want to get p by itself. We've got p minus 4. So basically we want, in the same as the other questions, we want it basically p plus 0. So if I add 4 to both sides here, add 4, 6 plus 4 is 10. Negative 4 plus 4 is 0, so I have a p on this side. 6 equals 10 minus 4. Notice I wrote it exactly the same as the original equation, but I replace the p with a 10. The left side is still 6. The right side is 10 minus 4, which equals 6. 6 equals 6 is true. At this point, I should mention, if you end up with 6 equals 14, or something weird like that, obviously you did something wrong. Either you did something wrong up here to figure out what p was, or you did something wrong in your check. But at the end of the day, if you end up with something like 6 equals 12, or something weird like that, you should go back and see what you did wrong. Please do not leave me with checks that say 6 equals 12. Also, please actually do your checks. Don't just write 6 equals 6, even if this is a 15. Right? If you have 15 minus 4, don't just write a 6. Actually, use your brain and go 10 minus 4 is 6. I'm going to write a 6 here. Or there is no point in doing the check. Okay, next one. 4 equals negative 3 plus y. And again, we want to get y by itself. Similar to last time, I'm going to add 3 to both sides here because negative 3 plus 3 equals 0. So on the left side, I'll have 7, 4 plus 3. Here I've got negative 3 plus 3 is 0, so I'm left with only y. Okay, and let's do our check. 4 on the left, negative 3 plus 7 also equals 4, so we did it right. Hooray! Okay, those were all adding and subtracting things on both sides. Let's have a look at something slightly different. On this one I've got 3x equals 15. I'm sure you guys remember, anytime we have a number next to a variable, it means times. So this is actually 3 times x equals 15. So in this case, instead of having 3 times x, we want to have 1 times x, because that'll just be x. So I want to divide both sides by 3. There's a couple ways you can do this. You can write a little division sign. I always write it as a fraction, because that's what you're going to see for the rest of high school. You don't need to write it that way, but you do need to be used to seeing it this way. 3 divided by 3 is 1, so I'm left with 1x, which is just x. 15 divided by 3 is 5. And now we have to do our check. We're going to write things exactly the same as the original. Notice there is no multiplication sign in the original, so I should not have a multiplication sign in my check. I'll just have a 5 in brackets instead of the x. And notice if I've got a number next to brackets, that means multiplication, so I end up with 15 equals 15. There we go, F. I've got negative 7b equals 14. And again, we want to end up with 1b. So I'm going to divide both sides by negative 7 because negative 7 divided by negative 7 equals 1. If I divided both sides by 7, I'd have negative 1b, which I don't want. I want b, which is the same as 1b. So negative 7 divided by 7, negative 7 is 1. So I'm left with just b. And on the other side, 14 divided by negative 7 is negative 2. Do my check. I'm going to write it exactly the same as the original, but with a negative 2 in brackets instead of the b. Notice no multiplication sign up here, which means no multiplication sign down here. Negative 7 times negative 2 is 14. So I get 14 equals 14 is the truth. Next one, G. W divided by 3 equals 6. Okay, and again, I want to end up with basically W times 1 or divided by 1. So I want to do the opposite of dividing. So I'm going to multiply both sides by 3. So if I take W, divide it by 3, and then multiply it by 3, I just get back to the same number. Basically the same as multiplying by 1. So on this side, I'll have W, and on this side I've got 6 times 3 is 18. Do our check, written exactly the same as the original. Notice there's a division sign in the original, so I want to write it with a division sign. If the original division was written as a fraction, I'd want to write my check as a fraction. 18 divided by 3 is 6, so I get 6 equals 6 is the truth. Okay, just two more examples. As usual, if I'm going too fast, make sure you pause and rewind. Okay, next guy. Got 4 equals m divided by negative 2, and this time our division is written as a fraction. And again, we want to end up with 1m. So I'm going to, basically I want to have this multiplied by negative 2. The best way to write it is write it as negative 2 over 1. Then we can think about it as two fractions multiplied together. Right, so we'll have m times negative 2 divided by negative 2. Negative 2 over negative 2 is 1. So we've got 1m, or just m over here. And here I'm going to multiply things by negative 2. And because this side isn't a fraction, I don't need to write it as a fraction. Negative 2 times 3 is negative 8. And again, write it exactly the same as the original, but with a negative 8 in brackets instead of my m. Left side is 4. Right side is negative 8 divided by negative 2, also 4. True. Okay, and one more. Got 3p equals 7. And again, we want to get p by itself. So we're going to divide, or sorry, we want to get 1p, I should say, not p by itself. So I'm going to divide both sides by 3. 3 divided by 3 is 1, so I've got 1p, or just p. And 7 divided by 3, I'm going to leave as an improper fraction of 7 over 3. Okay, time to do my check. I've got 3 times 7 over 3 equals 7. Okay, it's going to be best to think about this 3 as 3 over 1. And now I can just go top times top, bottom times bottom. Or I can reduce first, your choice. Let's go top times top, bottom times bottom. So I've got 21 over 3 equals 7. And now I can reduce this fraction by dividing top and bottom by 3, which gives me 7 over 1, or just 7. 7 over 7 is the truth. So when p equals 7 over 3, it makes the equation true. So p is the solution. Okay, I'll give you your assignment in class or online. Enjoy.